Thank you for that introduction, and good afternoon to everyone. My name is Winston Jensen. I'm the VP of Construction for Brookfield Office Properties. Before our esteemed colleagues get into the details of BIM and how it's been implemented into our project, I thought I'd give you a brief overview of the development and a few of my own thoughts on BIM, where it is now, and where it could go. And I promise not to say where no man has gone before. But we'll pass on the slides. But yeah, currently it's a full block development in the heart of Calgary's downtown business district. But it didn't always start off that way. In May of 2007, was when we purchased the easterly half of the site, which was called the Herald Block. And shortly after that, in 2011, we submitted for a DP on that portion of the site for a single 1.2 million square foot office tower. It was in May the following year that we got approval for that DP, but that same year we successfully purchased the Bay Parkade, which was the remainder of that full city block. So with the purchase of the remaining half of the block, we decided to up our game and submitted a new DP to the City of Calgary for a redesigned project that was now worthy of being elevated to the status of a world-class development. The following year, with the support the Mayor, City Council, and Development Department, we received our approval for that DP in record time and started construction in October of 2013, exactly 2 years ago today. So keys to success, I think certainly didn't hurt for us to have acquired probably one of the best undeveloped parcels of land in downtown Calgary. And with the help of our consultants and architects, we certainly upped our game with a world-class design. And certainly with the help of and support of the mayor and their various constituencies, as well as the various departments of the City of Calgary, certainly have led to our success thus far. So overall, Brookfield Place is a 2.4 million square foot development. It's in Calgary's, in the heart of Calgary's central business district, and it's, as I said, it's a full city block, access to major retail and restaurant amenities, and having the Calgary LRT at its doorstep. The full development is being phased. Currently, phase one, which is under construction now, consists of the 56-story East Tower and a portion of one of the key architectural features of the development, which is our 50,000 square foot Pavilion, which is 60 feet high, fully glass enclosed. Phase two will be the West Tower, 42 stories, and it will, during phase two, we'll see the completion of the glass pavilion. Just a couple of snapshots. The pavilion, as you can see, it's 60 feet high. It's 50,000 square feet. And this is looking north towards Bow Valley Square. The upper level plus 15, which is where our food court will be. And another look at what one of our food court units might look like. And this is a beautiful shot looking south towards Scotia Center up in the plus 15. So more specifically, the current development, phase one, the East Tower is 56 stories, 1.4 million square feet of office space. It will rise up 243 meters above grade, which will be 6 meters taller than the bow, and consists, not that that matters, and consists of 6 levels of underground parking. Construction, as I said, started 2 years ago today, in October of 2013. Our occupancy is slated for the summer of 2017. Our typical floor plate is just over 27,000 square feet, and Synovus, our anchor tenant, has currently leased 71% of the phase one office tower. And that kind of concludes. And just a few brief personal thoughts about BIM and my experience with BIM on our project. You know, I think part of my job is to manage the effective deployment of Brookfield's capital and to make sure we're either creating or adding value. And I guess the two big questions with BIM is, you know, what does it do and does it create value? And I think that quick synopsis, in my personal view with BIM, it seems to be a tool that enhances our contractors and consultants' ability to identify site conditions and interferences sooner than later. And I suspect that sooner than later does add some value. It certainly probably shaves a little bit of risk off our schedule. And certainly identifying issues sooner probably reduces the cost of those changes. So that's sort of my snapshot of where I see BIM today, and where I think BIM could probably add a tremendous amount of more value would be if we could move the process of BIM, which predominantly seems to happen kind of post-tender, post-award, if we could move that more up into the design phase of the project. And I think structurally we seem to be already there, but mechanically and electrically, where we tend to see most of our changes, which is obviously a pet peeve of ours, but I think being able to implement BIM sort of in that design stage and get to the level of detail that the Arpis of the world get into a post-award, I think we'd tremendously reduce the number of changes in our projects. Anyway, that's all I had to say. Thank you very much. I'll pass the reins on to Cameron Perez, Associate Architect for our project. Thank you.
Thanks, Winston. So my name's Cameron Veers. I'm an architect and principal at Dialogue. Been actually working on this job for the past 3.5 years. It's been pretty phenomenal. This slide really shows the complexity of the job. The consulting team is, we have 24 different consultants across 8 different time zones. That's a lot of people to coordinate and collaborate with. It also shows you that we had some real geographical challenges. The architecture was actually a collaboration between Dialogue and our design partners. Actually, it was both our design and construction partners at Arnie Fender Castellitis. They're headquartered out of London. Winston touched a little bit on project schedule, but just to summarize in this slide, it's about a 5-year design and construction process from the very start to the finish. Land use and planning approvals were 15 months. That involved development permit approval and DP release. During that time, we also ran the concept design and design development concurrently. Construction documents were 14 months with 9 bid packages. We started with shoring and excavation. Then it went into some of the last packages, had more to do with finishes, landscape, and some of the specialty glazing in the Pavilion. One thing Winston didn't touch on is the Pavilion actually has some very unique geometries. It's got curved corners in both plans and sections, which leads to some real technical challenges. In fact, the shoulders of the Pavilion, there's only one glass manufacturer in the world that can do insulated glass units in that geometry. In terms of team structure, we thought really early in the process we needed to define the flow of information, and we asked all of our consultants, or at least most of our larger consultants that were more involved, both basically mechanical, electrical, structural, landscape, our design partners. Everyone had to put together an organization chart that how their team was going to work. And this really meant it could define, the project managers knew which project managers to talk to, the BIM coordinators knew what BIM coordinators to talk to, and it really helped to have the flow of information both vertically and horizontally from one consulting group to the other. The preliminary design started in Grasshopper and Rhino. This mostly had to do with the ability to do parametric modeling. This was back in 2012. Most of the building form was done by our, like I mentioned, our design partners in London. They needed to get the geometry of the corners of the tower just right. The building actually, the corners start at a 600 millimeter radius and they taper up to 4.5 meters. So every piece of glass on the corner has a conical geometry. In fact, there's only 3 glaziers in the world that can put a low-E coating on a conical piece of glass. So you can see that there definitely are some challenges. The parametric modeling really helped to, like I said, get the geometry on the corner of the towers. There's some complex geometries at the top of the tower. The glass curtain wall actually turns back on itself, and again, it's curved in both plan and section. So it really helped to get that down. It helped to look at how we could maximize views from the inside of the building to the mountains and other city views. Also helped for daylighting and maximizing the amount of light we could get into the plaza that's on the south side of the development. So after we, I guess, got the design right in Rhino, when we started the Revit process and the BIM process in design development. And the first thing we needed to do was to take a lot of these complex geometries and translate them into a native Revit language. So there were no interoperability issues. Then we needed to figure out how to split the model into clear zones and really define sort of how the facade was set. There was sort of flat paneled glass, there was trapezoidal glass, there was the conical corners, there was the complex geometry in the pavilion. Then there was really how we were going to address what we called the building crown. So talking a little bit about the overall BIM setup with our consultants, the first thing we wanted everyone to do was to really define their level of commitment by signing a memorandum of understanding. And this, you know, it had no real legal basis, but as what it was everyone was committed right from day one on design development right to the end of the project and when we turned it over. So after we did the MOU, we went into a detailed execution plan. That started with a conversation with our client, Brookfield, about what they needed the model for, if anything. Are they going to use it for tenant coordination? Do they need it for project turnover, for ongoing operation and maintenance? Are they going to need it for tenant coordination? And then we went through a whole series of other very specific, detailed things to make sure that we had the right setup. Because we all know that getting this BIM execution plan right was really going to be the key to getting the project on track and having a successful BIM project. So specifically working with our design partners was interesting. They did start with mostly the model geometry, and then Dialogue's role was to evolve the design, work with them, and really start to get into more of the project execution. So this graphic shows how we worked and how we turned over some of the models. Everything was in line with the different bid packages, the 8 packages that I had spoken about. And we made sure that we set up this collaboration early. We've had weekly meetings for the past 3.5 years, every Tuesday morning at 7 a.m. That time works with the 7-hour time difference. It's gone from design development through construction documents now into contract administration. And it was really important that we had that constant communication. We've also had weekly design and BIM coordination meetings that happened sort of away from what the project managers were talking about, so they could deal with specific issues. We've talked about that we've actually implemented a dialogue template. That was important. Martin actually went to London and spent 3 weeks with the AFK team, training them on how to use that. And we also needed to make sure that the sharing of information was possible, and this was largely through cloud-based storage solutions like Box and Dropbox, and it was also through things like Smart Bridget, where we could actually share our screens, we could draw in real time, we could use the Navisworks model. That really helped us to be able to come over some of the obstacles of geography and time. So we also set up weekly coordination meetings with our consultants. Mostly they plugged in on the Tuesday mornings with all of the project managers to deal with the design and the technical issues. Then we also had meetings mostly during the production phase, where the BIM coordinators would talk to the various BIM coordinators, mostly to do with modeling issues, Revit coordination, project best practices, tender package delivery. And we also realized that we needed to make sure that we had an internal process and dialogue, that we could make sure we had education, we could look at best practices about our own internal staff, procedures and training. That really led into educating a lot of people on how our template operated, looked at even Navisworks training and utilizing that as a tool. We got into BIM 360 Glue a little bit later in the process for a lot of visual coordination. This was a great tool because we could actually use it in real time and everyone could comment because it was cloud-based. And it could get down to anything about door tags, schedules, and any process-specific items. So a lot of the design review happened with 3D models in Navisworks. We've also been utilizing things like multi PDFs, Bluebeam PDFs with hot links. I find it a pretty fantastic process when you can click on the detail reference, and the hot link will take you right to that detail. Gives you the ability to really quickly go through a set of drawings. I mentioned BIM 360 glue. We use Navisworks to set up a lot of presets for animations and views for client meetings to really help them navigate the model and visualize what was happening. This was good for both design and construction. Then we also got into fairly specific 3D interference checks with Navisworks class detection using Navisworks Manage. Martin set everything up so we could have color coding per system. We always had to go back and make sure that we were cross-referencing everything with our BIM execution plan. And part of that was, maybe you don't have the BIM execution plan perfect. I think there was a lot of evolution and a lot of growth, and we made sure that all of our consultants were on board as we made some of these changes. So we eventually, after we started to award a lot of the major bid packages, we agreed that we would get into the virtual design and construction. And truth be told, when someone said we are having VDC meetings, I had to look it up. I wasn't exactly sure what that was, but we fully bought in a model, get into some of the specifics of that. But in hindsight now, I can really say that it's been unbelievable. I know all our contract administrators are preaching its virtues. It's cutting down on the amount of change orders, or at least the value of the change orders, to be able to pick things up in the virtual world before you get yourself in trouble with maybe some of the sleeving through the core or some of the installation of the mechanical and electrical. The other thing I think VDC did for us was it got us in tune with the construction schedule. EllisDon would be beating us up a little bit about starting to focus on priority items in different areas of the tower, and we would realize very quickly that it was because this is going to become pretty critical on their schedule. So I think that this process is definitely the future. Winston touched on the fact that if we could actually start to engage some of the sub-trades a little bit earlier in the process, I think that would add an awful lot of value. So we found that our mechanical engineers at the Mitchell Partnership did a great job of modeling all the elements, but it's not to a specific enough detail that some of these coordination issues could be dealt with early enough in the process. So we've actually had some conversations with Arpis about what that would look like, bringing them in as a consultant, a specialty consultant in around design development, to start to get some actual trade information into the model. So in summary for my bit, I think our ingredients to success are our people. We've got a great team of highly skilled and dedicated people. I think we've got great leadership, not only from the top, but we've got great leadership on the BIM side. We've got great leadership on our production side. Communication is critical. We established key communication protocols early in the process and made sure that we implemented them and we stuck with them. In terms of process, we had a definite clear plan and project execution strategy that made sure everyone was pulling in the same direction. In terms of collaboration, I mean, to get, like I said, get 28 people all pulling in the same direction, we definitely did have the buy-in early. And then the last one was software. I think the software was really just the platform that needs to support the team. That there's more than just Revit and Navisworks. It's a whole process. So, thank you very much.
Okay. My name is Ian Trudeau. I'm an associate at Intuitive. I'm also on the board, so you might have seen me yesterday here. So this project was a very important part of Intuitive's growth, actually. We're a relatively new firm. We're going to turn 5 in January, and we started designing this, it was, I guess, over 2 years ago now. So we were in the position where we needed to get our standards developed in the right way moving forward so we could progress the firm appropriately. So this project represented a number of things that we were trying and that we've since implemented for most of our projects. So I'll just highlight a few of those. I'm not going to get into the broader project too much since that's been covered, but one thing in particular, you've seen pictures of the crown. We've talked about the complexity of the geometry. So we did things like creating these nested families that allowed us to adapt our model very quickly to the geometry as it was getting adjusted, because we were working fairly early on as this was getting developed. And it allowed us to keep the steel fairly accurate, within millimeters, I'm told, in some cases. So it was pretty effective technique. And obviously you get the benefit of having a rich level of detail in the graphics, and we can describe loading. The loading's very complicated on this crown structure in particular. Different wind loading happening in different places, so we were very easily able to describe that. Another decision we made on this project, and something we've implemented going forward, is to bring our bigger projects to a level of detail which I call 350. You see the level of detail tables, and typically designers go to 300 and then hand it over to the fabricators. But on this job in particular, there's significant embedments, you could say, under these columns, for example. That's a 4 to 6 inch piece of steel underneath the columns. It's a fairly significant element. And the number of cast-in plates, as you can see on the left there, in the core to pick up the composite trusses, that adds up over 50 some odd stories. So to capture these in the model is important for us, because we want to be able to quantify these things. They represent a significant cost item. There's a significant amount of material. And something we're doing is trying to track all this on our projects and have an understanding of what we're putting into these buildings, and have a database of that information. So this is something we've done going forward. There's a typical elevation. So obviously the core is complicated. It's a tall building. And we've worked fairly closely with TMP. We have a good relationship with TMP as well as Dialog, of course. And we develop a process where they've modeled the sleeving for us on most jobs that we do together, so we can quickly isolate that element and get the actual size through the core. Of course, it's at the level of detail that we can get to during DD, but it allows us to overlay our zones onto our elevations, our rebar zones, I should clarify, so we can make sure we're not penetrating those areas. So that's the shaded part you see there. So this is exactly what goes on our drawings. It's very clear as to where everything is. And it's all coming from the model. So the Pavilion in particular was a very interesting piece. It's almost its own science project for us. As it was mentioned, it's sort of built in two pieces. So it's posed a challenge structurally. It's a single structure meant to stand as a whole, and we had to design it to stand as a half. And to further complicate it, every piece of steel within that structure is a custom section, as you can see on the right. So I'd be hard-pressed to imagine how you would visualize that with stick lines on a plan. So we were able to produce these sort of 3D views, high level of detail. It's very clear what's happening. And of course, we provided dimension sections and such, but at least you could see how it fit together. And this little model here is actually a mock-up that was built, so you could visualize it on site and get a sense of the scale. The biggest thing I would think on this job, and this is something that we've definitely carried forward, is embedding more information into our models and focusing on quantifying better materials. So we've, within the parquet and as well as all the steel, we modeled the material strength of all the concrete. So what you're seeing here is a color-coded model. The colors represent the different strengths of concrete. The theory is the lighter the strength, the lighter the concrete, the darker the strength, or the darker the color, the higher strength. And it allows, having the colors allows the designers in our office to quickly do a check to make sure that we're showing the right materials in the right places. And allows us to quickly quantify the different strengths and have that. And of course, this was a result of having discussions with different contractors in our area. We've talked to EllisDon, PCL, Pomerleau, and we want to make sure that we're doing this so it's beneficial for us, but also for the downstream users of the model. So this was a result of that research that we did in the market, and something that we do on every project now. It's built right into our template. We even went to the level of detail. This is a typical sort of column elevation. We've modeled the puddling around each column. I don't know if you know anything about structure, but we'll puddle high-strength concrete around each column to sort of transfer the load effectively. That adds up, again, over several columns, several hundred columns, I should say, and puddling around each one. So that's a lot of high-strength concrete we miss capturing if we don't model it effectively. And as well, we embed the loading for each column right into the properties within the element, which basically creates a schedule that's a byproduct. We didn't have to draw any of that. It's all there. Our engineers can input the loading directly from their column rundown sheets. There's effectively no drafting. It's just building the model properly. The other complication with the phasing is that we had to understand the full impact of phase 2 on phase 1 project. Since as phase 2 becomes built, the two buildings actually act as one structurally. They are connected together underground. There's no separation joint. So we had to fully develop a model for phase 2 and analyze it to understand the impact on phase 1. So we spent a lot of time doing that, actually. And what you're seeing here is a view from the phase 2 model looking at phase 1 as it's being built. So the bracing you see in the middle there, that's the temporary sort of structure that holds the pavilion up until the second piece is built. And then the blue sort of squares, those are all the future knockout panels for the cars to go through that wall once the second garage is built. And here you're saying the faded model would be phase 1, and then the new one in the front is phase 2. So we remove all the bracing, temporary bracing, and finish the structure, and now it functions as it should, as one building. Another interesting piece, and we'll see a little bit more on this once Hamad comes up and we start talking about shop drawings, but the transfer girders on the north side of the tower, the north side of the tower actually comes down on top of a drive aisle, which is not very useful when you're trying to design a parking garage. So we had to transfer out the tower columns at the ground floor. And just to give you a sense of scale, these transfer girders are about 10 feet deep. And I had a few notes here on them. Very interesting facts here. So the mid-span transfer girders, the ones that pick up the interior columns, are supporting 4,200 tons, which translates into 92 million pounds each. So that's a lot of weight. And again, try and represent this with a stick line on a plan is not very effective. So there's a lot of details around these, a lot of 3D views. And we'll talk about how we reviewed these in 3D as well during the shop drawing process, because it's, again, just looking at it in 2 dimensions isn't always as effective. And there's just a photo of that thing erected, and I don't know if this has a pointer on it or not. If you look here, that's a human there, and that's the beam. So it's quite large, and we'll see some more information on that. So that's all I had. I'll come back up later and talk about the shop drawing process, but for now I'll pass on to Hamad.
Hey, my name is Hamad Chaudhry. I work with EllisDon Construction. I want to thank everyone so far. So one thing with EllisDon is they're not new to BIM. They've done many projects in the past. However, one thing that we've noticed is there's different levels of adaptation within the community. Now, what that means for us is we've got to be able to be the glue that brings the owner, the consultants, and our subtrades together. It's not necessarily an easy task, as you can imagine, but given the fact that we've done it before, we have workflows we can sort of take as a baseline and improve project to project. So in that sense, it's not the first BIM project, but for the group that we're working with as a team, it was the first BIM project in that sense. At EllisDon, it's really a top-down approach because our CEO himself says BIM's not the future, it's happening right now. And as we continue, hopefully you'll see why. So on this project, we did use BIM in various facets. So there was pre-construction, right? We did sequencing and all that to make sure that we could bid competitively on the job and make sure that we would be awarded. But at the same time, we didn't use all the 3D, 4D, 5D, 6D, 7D, etc. on site during construction. Our main focus was on 3D And when we could, we did facilitate the schedule as well and looked at cost implications. Now, the biggest thing for a GC or a CM is risk. And we want to make sure that we're risk savvy and we know where it's going to lie. So by having 3D coordination, we're able to build on that old saying, measure twice, cut once, right? This is sort of build it virtually, and you know when you go on site, it's going to work out. So that's sort of the logic, and hopefully going through this presentation, you'll see how we've been able to achieve that. The first thing is setting up our BIM Schedule A and giving the consultants and the owner feedback on the spec. With our Schedule A, we sort of add our own expectations, you could say, in there that we want our subtrades to have. Sometimes it's very specific, other times it's a little open to interpretation because we know project to project there's going to be a lot of variances. When it comes to the project specifications, sometimes we'll see that maybe the design team or whoever make it too specific, like you have to use Revit 2014. That's not fair because we've got subtrades from all over and they use different software groups. So we want to make sure that we're using the technology that we got and the process and making it work and not limiting anyone. And we're always open to that. The next thing we did was created a project-specific BIM execution plan. Now I know it's been heard a lot lately, but it really, really is critical. The reason for that is it gives us an understanding of which subtrade or which company is using what software, what kind of file formats are they going to be using, you know, who's capable of what. What we did in the beginning was we toured site offices for each trade that got awarded and was going to be a heavy player with the BIM process. So we'd go down, look at their office, see what their workflow is, so that we could sort of manage this process and make it work. So I mean, just to give you guys an example of all those softwares, we got Revit, AutoCAD, AutoSprink, Tekla Structurals, and Trimble, 3D CAD, Fab, or whatever the mechanical guys use. What the issue with that is we've got IFCs, DWGs, .rvts, and a bunch of other formats that we're getting. And we don't want to be spending time managing these files or converting them. We want to be using them for what we got to do. So by having this set up, we know what's coming, we know what we got to do, and there's a little time wasted in that sense. The next thing that we did, and Ian was sort of talking about it for the transfer girders and the steel, is we set up a 3D shop drawing review process. And it wasn't sort of a Bible by any means. We were reviewing it as we went on. And the reason for that is there wasn't too much out there that we could rely on to give us an accurate indication of what we wanted. That doesn't mean there wasn't the resources that we used to sort of formulate this. All it means is that maybe after a couple of days or in the first month, we changed the document 5 to 6 times, right? We were learning things that we couldn't preemptively see. And in a way that was very reflective of the VDC process, because when we want to build something, we don't always see until we go to build it. So I thought that was pretty interesting. So here's the example of the transfer girders. So we had almost like 80-something pages to review, PDFs. And you know, if you were going to do that traditionally, 60-something plus pages to 100 pages, depending on what component you're looking at, comes to EllisDon, we review it, send it to the prime, they send it, and then back and forth. That takes a lot of time, and sometimes time is not something we can waste, right? So this particular review was very critical for that, because the way we started tendering the job is sequential, and by the time we got the steel going, concrete was already being poured, so we were running against the clock. So we implemented this 3D shop drawing review. It cut the time down significantly. As soon as Intuitive or anyone would go on there, make a comment, our subtrade was able to log on and see right away what happened. We were able to archive all this information, so in case something does go awry, which is not going to happen, but we have it backed up. So that was a very beneficial aspect of doing 3D shop review. Another thing was we could tag all the items that we needed to be modified or were reviewed as noted and all that kind of stuff right off the bat. So when you're sitting there and you're a subtrade, you're not waiting for 7 days or 10 days, whatever you have in your spec. You're there right away within the hour. You know that, oh, okay, this bolt's not going to work. Oh, sorry. You know the bolt's not going to work, or you got to update something, show more calculations. And at the end of the day, each transmittal that we did with this went back as reviewed as noted or approved because there was no need to have it resubmitted. There are some downfalls though. Not everything can be embedded in the model. And maybe it's a little bit of a software limitation, but I mean, as a community, as you guys are now aware, we're only getting there. That's becoming common practice. So as time goes on, I believe, we'll be able to have everything that we need to review within the model environment. But at this point, on this project, we did not. So moving on to the 3D coordination aspect, what you see on the left side there, that's the design model. That's what we got from the consultant. So there's a lot of information on there. But like I said previously, there's a level of detail 300. So it's not fully fabrication ready. As we jump forward with our subtrades, a lot of issues become apparent, and that's the picture on the right there. And because we're doing this virtually, we're able to rectify these issues, maybe add a bulkhead, change the partition, change the layout, revamp what we need to make sure by the time the guys on the site get there, there's not going to be any holdups. So right here is sort of a case study. So this is the parkade. If you look what is this? How does this work out?
It's on the bottom.
The lasers on top.
Oh, there you go. So if you look right here and right there, that's the transfer girders. So it's a really big piece of steel, so you can't sleeve through it. However, during the design coordination, I guess that was overlooked, right? I mean, they're not going to be perfect. So they're sleeving about 16 conduit. Each is about 3 to 4 inches through a big structural member. So obviously, when we brought this up to Intuitive, they told us no. So we worked with our subtrades, and we ended up with this. It may not look like much. However, if we were to do this on site, we would have not been able to achieve this. It would have set us back significantly. The cost, we don't want to put a number on there, but it would have been really significant. And overall, the delay to the owner. So this is just one small example. And here's another view of it, just from the corner. So what you're looking on the left is our finalized layout. We revamped everything to make sure that it's going to work within the clearances, height requirements you need for the parkade, and also making sure all the services that we required were going to be provided and we're not missing out on anything. The level of detail that we went to was pretty significant because we got a lot of feedback, not only from the owner, but all the way down to the subtrades, saying that they're really happy to be involved in this process. And although maybe everyone's not seeing the value up front, eventually when this project's done, each company will be using this as sort of a benchmark. Here's another heavy level. So this is our mechanical room on level 3. On the left, again, that's the design one. On the right is the fabrication one. So this room, I've been told many times, would not have been built unless we used VDC. And the reason for that is there's minimal clearances, big equipment, very tight, and no room to play. Happily, Arpis used this information, and they were able to get everything prefabbed, and Jason's going to touch on that a little bit when he comes up here. But so far, we're not fully done on site yet, but if you guys go by, you can see we've got about anywhere from 20 to 40% of the floor going right now with equipment, and it's been going pretty decent. So the detail on the left, if you're from a design background, you're looking at it and probably like, that looks pretty cool, pretty neat. But if you're a construction manager or a GC, you're looking at that and all you can think is risk. And I mean, it's fine, right? But that's what our job is. We want to know what the risk is so we can build it properly and not have any time delays. Now, the image on the right is what we ended up with after we got all of our subtrades on board and obviously countless meetings with the consultants to finally get something that would be achievable. We've virtually mocked it up. So now we know 1 millimeter in virtual reality, or whatever you want to call it, is 1 millimeter in real life. If there is any variance, it will be human error. That's sort of where we're going with this at this point. We feel fairly comfortable that we've done a lot of coordination on something that otherwise we would have at least taken 2 to 3 times the amount of time and resources to achieve. Again, this is a look at the pavilion. This is just sort of the corner. So we're able to quickly isolate any element, cross-compare it to anything else. So if you want to look at how structure and mechanical are reacting, it's only a couple of layers you got to hide, and you're able to do that really quickly. What's the benefit to that? It's countless, because we've got site superintendents who have 30+ years experience, and these guys can build stuff while they're sleeping, right? But when you show them this and you really sit down and walk through, it's almost like a light bulb goes off, and they're able to sort of build on what they already know and utilize the resource we have, and it's really helped on site. So I'm not going to say that we've been able to surpass schedule, because I don't think that's true, but we've been able to keep up to our aggressive schedule, and that is very much in part to BIM. So here's another example. We went from large systems, right, steel all the way to mechanical, electrical, and now we're going down to signage. Now, how many people in this room have thought about coordinating signage? One person. All right, we got a couple, but it's very small. The fact that we were able to coordinate signage before we've even tendered it or even put a tender package together for this item is great. When we sat down with our signage consultant, Entro, we eliminated a handful of signs because we realized sprinkler or sanitary lines are going to be in front of it, and we came up with different solutions such as wall paintings or whatever. Now, in reality, compared to the other meetings that we've been a part of, this was very, very small, very short. However, the impact at the end of the day for Brookfield is they're going to have signage that they know will work and is going to be clash-free. So in order to wrap up what I've been talking about so far and give Jason a chance to get 15 minutes of fame here.
We're almost there.
5 minutes, sorry. So we started with the VDC process when construction was already ongoing. So we were already excavating, concrete was going. We got the mechanical guys on board and the electrical guys, and then we started doing the VDC process. We were able to keep up to construction and surpass it. And now, you know, the picture on the top right, that's where we're at now. The picture on the left is the crown. That's what we're aiming to coordinate within the next couple of weeks moving forward. So this process has not only been effective for EllisDon, but it's also been effective for every member of the team so far. From our standpoint, it's helped us reduce the amount of RFIs or get a quicker response on RFIs that we know are going to be critical. And overall, in the industry, I think one thing to keep in mind is the whole BIM process is a cultural shift. And anytime you have that, it's going to be incremental. So the point that we're at now, I think we're doing really well. And moving forward on the next project, I know everyone on this team, we're going to be able to really improve and add some more value. Thank you. Jason?
You
Or Ian? Sorry.
No, it's Jason. Just flip from my side.
Hello, my name is Jason Penoyer. I'm the project superintendent for Arpis Mechanical, working at Brookfield Place. We have an in-house BIM team of 4 members. Each member is a ticketed tradesman with field experience, and that certainly brings a lot to help me on site. So we've talked lots about BIM today. Let's talk about how do we take BIM and turn it into construction. The bottom left-hand picture there is the 3D model for a level 3 mechanical room. We can take it down, we can break it down further to the, up here we have, that's the hot water system. We can break down different sections, and from there we have spool drawings that are generated. The spool drawings are given to the foreman, they're given to a shop team, and there's a further breakdown of it, and everything comes prefabricated. At Brookfield Place, we have roll groove pipe, and I don't even have a roll groover on site. Everything is done prefabricated off-site, comes to site, it's put in the hangars, piece A is attached to piece B to piece C, and it's been working like a charm. This is just an example of a pump skid. The pump skid, it has an inertia base. The inertia base is built in the shop. The pump is mounted. All the trim and all the detail piping is added on. That's brought to site, and that'll be flown in by a crane. We bring it to site, and it's simply 2 attachments to hook onto the other spools from the previous drawings that are already there. This certainly streamlines our process. We don't have cumbersome material on the way on site. We've probably reduced our crews in the mechanical room by 50%, even though we still do have labor to it because it is done inside a shop, but it's done on a bench, so it's much more efficient. We also have sleeving drawings that we developed from the model. So from the model, we're able to make sleeving drawings. So the sleeving drawings are then sent out to the consultants for review. The exact same drawings are used to do layout in the field. And we're also able to troubleshoot areas where maybe we'd be into a ceiling or something, and we could start looking at with the architects ahead of time and decide where to move the sleeves. Brookfield Place has a 1050 mil core wall, so we certainly didn't want to miss any sleeves, and we haven't, so in the walls. That's going out really good. Lastly, we have our site information drawings. One of the trouble things for mechanical on the job sites is the plumbing pipe. The large plumbing pipe is bound by codes and grades and elevations and will oftentimes interfere with a light fixture. Maybe there's a ceiling. I know the architects are really keen on their ceilings in the lobbies, so we have to be cautious in these areas, and we're able to show them some problems that we may have encountered, and we can solve it ahead of time before construction even starts. This significantly reduces the RFI process. I've put in very few RFIs, and we do all the coordination ahead of time. The same drawing is also given to the field staff. They can work off of this 2D drawing, and then they have access to the model on site. There isn't a day that goes by that I, as a superintendent, do not use the 3D model. It's on my laptop, it's right there. Everyone comes in, the foreman can come and see it. They'll see a clouded area. They'll ask me questions, why are we doing that funny offset? And you'll have this pipe with what looks like a strange offset. But then the next trade comes by and they put in a large piece of equipment, and then all the pieces come together. You see why you had what looked like a strange offset in your piping was all of a sudden room for a fan coil or for some component from another trade. I have full buy-in to the BIM program and working into construction. I know Arpis has been doing it for a long time, but as this project superintendent, it certainly makes my life much easier. So I'm pretty happy for it. And that's it. Thank you.
I guess we'll take some questions. I didn't do my part, but Ahmad kind of covered the shop drawing process, but in the interest of time, anybody have any questions?
It's been repeated many times, probably will a few more times in this presentation, and sort of the forum, really. But now, seeing what you've seen with Brookfield Place, do you, and I'm speaking specifically to the general contractor and the consultants, do you feel like the next job you'll pull the sub-trades in earlier? How much earlier?
As early as possible. I mean, I think you're only really going to start seeing the full value of VDC if we can start to get sub-trade input. I mean, Jason mentioned that, you know, he's got ticketed guys that are actually installing pipe, doing the VDC process. So otherwise, I mean, we're really just drawing sort of no-fly zones where mechanical and electrical equipment can go. So we don't really know if, you know, the pipe hangers and the fittings and all of those specific details. You know, maybe some of the guys from the consultant teams could do that, but I think they'd be taking a lot of guesses. So it's almost like we need to look at project delivery and, you know, how that's going to interface with VDC.
I'd just add, it's kind of happening in some extent. Depends on the contract type, but we do a lot of P3 work as well. So, you know, before we even get into heavy CDs, we're already sitting down with the former trades and the rebar trades and working things out before we even put pen to paper. So it's happening more and more. Just depends on the contracts, right?
So this question's for Jason. What are we missing? Like, what's the next step to get the guys in the field to fully see the plan and work the plan? Because
I think getting the guys in the field engaged is probably the next step. And it has to be a collaborated effort. It can't just be mechanical. It has to be all trades. It has to start with the structural trades, understanding the importance of why do we want that sleeve in that area? Even though maybe it's a difficult area with zone steel and with a header, why do we want it there? So everyone just has to be engaged and understand it. There's more to it than just my trade. It's everybody. It has to be a collaborated effort.
thank you.
guess that's it. Thank you.